Sketch a graph of the following piecewise defined function. All right, the way this is going to play out is at x equals 1, we have a differing of functions. Okay, so to the left, less than 1, the function is going to look like x plus 3. So I can graph this just like I would any other function, any other linear function. X plus 3 with a slope of 1. So it's going to come up to this point, and I'm going to put a hole there because it's less than 1, and we're not including that point. Now, to the right of 1, we have x minus 2 squared, which is a quadratic function that has a vertex there at 2, 0. It's going to look like this. Now, it is going to come up to the point, if I evaluate that at 1, that is 1. So it's actually going to do something like that. Notice it's equal to on the quadratic side of things, and as an open circle or an open dot on the left side of things at the linear function. Let's look at another piecewise function. In a big city, drivers are charged variable rates for parking in a parking garage. They're charged $10 for the first hour, or any part of the first hour, and an additional $2 for each hour or part thereof, up to $30 for the day. The parking garage is open from 6 to 12, 6 a.m. to 12 midnight. Okay, the way this cost function, c of x, is going to be defined, let's write that differently. We have a pretty big function actually. It's $10 as long as x is between 0 and 1, actually including 1. Up to that first hour, it's $10. Okay, up to 1, it is $10. Well, it's $12 if you are between 1 and 2 hours, $14 between 2 and 3 hours, all the way up to $30 if it is between 10 and 18 hours. So the graph of this function is going to have a lot of holes in it, and here it is. It is $10 between 0 and 1, up to, and it's including 1, and then it's $12 between 1 and 2, 14, etc. It jumps by 2 each time. This graph is very discontinuous, if you notice. There are lots of places it is not connected. Lots of places it's not connected.